Hi, this is Maarten Visser of Flute Lab, and this is video 3 of the Adaptive Woodwind design series. Previously there are 2 other videos. One is about an introduction and the other one is about the consultation session, and especially the latter is essential viewing as it's an important part of the design process. So this movement is about how to get from a concept of design to final design. It's not a general movement about woodwind key design, but there's of course a strong overlap. And this is a field in which there is practically no literature. So we will have to do with this.
Are there some general design rules in making adaptive woodwind?
Yes. First of all, the thing where you start is with instrument holding and support. Sometimes that's all you need. An adaptation can be as simple as adding a simple thumb rest or a complete support system. There is a discussion about this already in the previous video, but it's an essential and important part of making woodwind adaptations. Another big design rule is, of course, keep it simple. Simple to make, simple to construct, and especially key interactions where one key works together with another key. It makes the construction exponentially more complicated and time consuming and thus expensive. Your work, your instrument should also be simple to play. There's 2 levels to that. There is on the motor level, the easiest thing to do is push your finger, close press a key, close a hole or open a hole. But sometimes a finger has to move from one key to another, or press 2 keys at the same time. So that's another level of difficulties. And here, the easier, the simpler, the better. And there is another level yet of difficulty, motor difficulty, which is where a continuous feedback loop is needed. For example, like you have in the embouchure. If you can, avoid it, because it takes a lot of concentration to play that way. There is also a cognitive level, to cognitive side to ease of playing, and that way of learning cognitively is very much rule-based. So the fewer rules, the better. And of course, rules should not be contradictory, but consistent. And a lot of our customers already have years of playing experience. They have a long history of their instrument, and the new rules of playing should be consistent with what they know, with what they're experienced with. The instrument should also be easy to assemble and to clean. For example, if you only have one hand, one functional hand, that can be complicated, and you should to find out a way your customer can do that. What you make should also be robust and strong, because people will play on it for hours and hours and then take it to lessons or rehearsals. Instruments that we make should be good looking, not just for the fun of it, but it will be easier for people to accept to have an adaptive instrument if it looks like a real instrument. If you have an adaptive recorder or an adaptive clarinet, and it looks like a real clarinet, only the other clarinet players will see, hey, this is a bit unusual. I used to make adaptive recorders for young children, and I told them that because of all their keys, their instrument was actually better than the recorders which did not have the keys. And I polished them highly, and I had them plated brightly, and they loved it. And that makes learning to play easier, more fun. So looks really do matter. One more design rule is, it's a very general design rule, that 1 hour of designing saves you 2 or 3 hours of improvising around. So it's definitely not wasted time, the time you spend on your computer or your drawing table. I have a small example here where the customer had trouble finding the exact hole position. She didn't have a lot of feeling in the fingertips. I made a small insert to the tone hole rim, so it raised the rim just above the surface, so she could easily feel it. Of course, the rim had the same inside diameter as the tone hole. And no key was needed, very simple to make, and it solved the problem for her.
What are the possibilities to add support?
You can add some fixture to the body. That's usually the easiest. If this done well, you should have tried it out during the consultation session. And now is the time to fit it to the instrument. If you have a metal instrument, you can fit it with a plate which fits the body. Here I have it, a support system fitted to the flute. The lady who plays this instrument can only close her right hand tightly. She can't operate keys. So it has a handle with a sturdy fixing to the instrument, and it has a large solder surface, so there is a strong connection between the support system and the flute. This is usually an area in which a lot of force is concentrated, so it should be plenty big. On the one on the photograph has 2 brass bushings with M4 threads, which is very easy way to add all sorts of supports. Also, here's a clarinet, and it has a quick fix plate for a photo tripod or monopod. So the plate is fixed with 2 screws to a brass plate, which then is fixed to the body of the instrument. So I milled a flat on the body. You can also use a curved plate, and you don't have to mill anything. And I spread the force over quite a large, like eight different screws, eight screws. So again, not all the force is concentrated on one point, and this construction can take a lot of force. The screws I use are typically the thumb rest screws. I have another support system here on a tenor recorder, and it's just a cylinder on a base which is fitted to the flute with I think 6 small screws. Again, to spread the force and not to break the wood. It was the idea of the player to use a fiberglass fishing rod, and it's a bit flexible, works wonderful, and it doesn't weigh anything. Lovely idea. If you need some really sturdy floor support to hold the entire instrument, what works very well is a cymbal stand. This is the Pearl B1030 cymbal stand, and if you remove all the cymbal holding parts, there is a thread M8, and very easy again to fit all sorts of things to. Nearer to the instrument, where the hand holds the flute or the clarinet, things become more sensitive, and you will have to invent all sorts of things. Again, this is something you should have tried out during the consultation process. And as people play on the instrument that you adapted, they change over time. They want more freedom in their hand. They need the support changed a little bit, so it becomes a little bit of a work in progress. It's part of the work that we do. It's normal. Especially on the flute, the holding is very sensitive because it is a part of the tone formation, and it's a difficult thing to hold anyway. So I have a couple of 3D printed parts that are clipped to the flute, and then the customer asked me, can you change this, can you change that, and the 3D printer is a great help in this. In the previous video I already discussed the conflict between freedom of movement and stability of support. So I suggest you look back at that if you haven't already. And one more thing about support. Most of the support of the instrument is of course done by the player himself or herself. And one thing you should avoid is uninterrupted use of one muscle or one muscle group. It's very fatiguing. What we do as humans in our body, we change all the time. You stand from one foot to the other. And if you make a support, do allow the player to change the weight of the instrument, to change his balance. That's why you often need multiple ways to support your instrument. For example, a strap and a thumb rest. So you can change your balance from time to time. Makes it much easier to hold.
What methods do you use in designing?
Oh well, many methods. My main design instrument is CAD software. I use Rhinoceros, but it doesn't really matter which CAD software you use. Particularly useful is to make a cross-section of the instrument and see all the angles there. And of course you can design entire keys, and if you are going to 3D print keys or have them cast, you will need a CAD software to make solid models. But I also use pencil and paper, and what I do, it sounds like children's play, but I make a photograph of the instrument with or without keys. I then print it in black and white, not too dark, and then I can draw over it with color pencil. If it's a dark instrument like a clarinet, I have to glue on pieces of white paper on places I want to draw, otherwise it gets too dark. It's a very simple way to work. For the position work, then I use the CAD software. And of course, there's always paper and rulers and calipers, or a drawing table like we used to do in the old days.
How do you design a woodwind key? Okay,
well, thanks for asking. Let's first look at the anatomy of the key. The first is where you touch the key. It's the part you call the touch piece or the spatula. Same thing. And it can't hang in the air, so it needs a connection to the movement, which are called the hinge. So there is an arm to the hinge. Then of course there's a pad, and the pad is held with a cup, so you have to make a cup. And the cup again is connected with an arm to the hinge. Then you need a way to stop the movement of the key, so to limit the range, and that's usually done with a kicker. And the kicker is its own arm. Then of course there's a movement system. You have two pillars or more. and either steel rod that goes through the tube or 2 point screws. Point screws easier to construct, but more time consuming to get right, because they must work without play, or you will introduce leaking and movement. So for practical reasons, hinges with a rod through a steel rod are the easiest to construct. And of course there's a spring. One side is the spring, goes through a small hole in the pillar, which I advise you drill before you fit the pillar to the instruments. And the other side of the spring goes in a spring hook on the key. And then a lot of the keys interact with other keys. For example, with a small cam, like on this old Haynes flute with an adjustment screw. And of course, more interactions between keys, the more complicated. So I'll keep it at that. There is a bit later on key. A bit later, I'll talk more about different types of key interactions, and I have a next movie is about the calculation of key interactions. Touch pieces can have many shapes. Flat for general use. You can have convex or concave. Convex, so rounded off on the top, makes it less stable. It's easy to slide off the key with your finger. So it's easy also to change from one key to another, like on these oboe keys. But if you only have one key for that finger, it's better to make it a little bit concave, like on these old typewriter keys. You can have even more different shapes. I have special shapes to stop the finger from moving off the key, like on these photographs of a flute and a recorder. About touch pieces, you also have to think of the trajectory. The trajectory of the touch piece must sort of coincide with the trajectory of the finger. You have plenty leeway there, but it should be with give or take 30 degrees. The pad cup. So you have tone hole, and the hole must be covered by a pad. And the pad should be at least 3 millimeters larger than the tone hole. And then you fit the cup around it. If you think about the trajectory of the pad cup, it is best if the pad lands exactly squarely on the tone hole. If it comes in at an angle, it will not close very well, and also the life of the pad will be very short. So that means that the movement, center of movement, should be in line with the top surface of the tone hole. Now we have some leeway, let's say 10 degrees up and down, and that gives us sort of a safe triangle in which we should find the center of the pillar. And if we have, for example, a pillar of 8 millimeter high, so the desired pillar position finds itself on a circle 8 millimeters from the surface of the instrument. And that circle and the green triangle will intersect at some point, and that gives us a safe space. That's where we will put our pillar. And usually the angle of the pillar is at 50 to 60 degrees from the angle of from the center of the tone hole.
How can keys interact with each other?
Most used is the inline cam or bridge. Here's a very small one on the D key of an old Haynes flute. but they can also be a little bit offset, like on the split E mechanism of a flute. I have a photo here of a one-handed saxophone I built, and on the left you see the G touch piece, and it pushes up the lever of a long rod, which in turn opens the G key. These are two levers which work opposite of each other, and it introduces a lot of friction, and that's why you see there is a roller to reduce the friction. The felt is there to reduce the noise. Next you see is the D key. It's the D to F sharp, which is present on all saxophones. It's a construction. It's an inline construction. There is no friction there, nothing special going on. On the right, you see the low B connection, and it works on a system with a string and a pulley. It introduces a lot of friction into the system, so it gives a lot of design friction. It gives a lot of design freedom, but it's hard to play. Even though I use a Teflon tube, so you can use it, but it's a lot of work to make and heavy to play, but it's there if you need it. Sometimes the key interactions, the movements are not parallel, and you have a one-to-one connection with screws. Then you can use ball heads, and they solve the problem, and they're often used on conical instruments such as saxophones to make key connections. Then you have more complex key interactions like automatic octave systems, or in this recorder which I built years ago. If you can, avoid them, because they are very time consuming to make and thus very costly. So next video is about how to calculate the length of key arms. So that's about this part of the key design.
Can you move a tone hole to another position?
Yes, you can, if it's around the tube. So the distance to the top of the instrument must stay the same. So for acoustical reasons, a tone hole has a depth, which usually often is the depth of the wood, the thickness of the wood, on the height of the tone hole rim on metal instruments. And acoustically speaking, you shouldn't look at the diameter, but at the surface area of the tone hole. And if you have to add two tone holes, you think it doesn't happen, but it happens, like here on the recorder. From a F and F sharp tone hole, I make one F tone hole, and I do that by adding the surfaces. It is very much the formula of Pythagoras, because it is the formula of Pythagoras. More calculations are really outside the scope of this video. If you're interested, I recommend you read Acoustical Aspects of Woodwind Instruments by Nederveen. Mr. Nederveen unfortunately passed away, but his book is fortunately still there. It's in the description of the last video of this series.
Can you 3D print keys?
Yes, you can, and I have many times. FDM printing is usually too rough, but it can be used to validate your design. But to print real keys, you should be using resin printing. Most resins are too brittle to use on instruments. They will break too easily, so you must use a tough resin. And to provide enough strength, they will these keys will become rather fat, rather clumsy. So it's difficult to fit them in between existing keys on woodwind instrument. But if like flutes or clarinets, but if the instrument does not already have keys, like a recorder, then it's very possible to use 3D printed keys. So these examples are from recorders. I 3D print the bass in one piece, complete with the holes to fit them to the instrument, with recesses where I can insert a small nut, a small M2 nut with a tiny drop of glue. And I also make a hole where I can insert a metal bushing which then holds the spring. Also the key you print in one piece with the cup and the kicker and the spring hook all in one. And the good thing about this process, of course, you can try it out. If it doesn't work well, you can print something again. Of course, you cannot use melt glue for setting the pad, so you have to use something like an acrylic or silicone glue. The durability of these keys is not as good as with metal keys, but they will last for years, is my experience, but not for decades.
How much will it cost?
Well, that is of course an important question, and your customer will know and will want to know that too. And of course your customer will have to agree to the price before you start making. So you will have to make a quote and give a price before you start making, and that is a bit difficult. So the elements of the price are labor costs, and that's the most, parts, a case, and shipping. And the labor costs are especially important if you often do this, because if you make an adaptation to an instrument once or twice a year, and you make a loss on that job, that's not a drama. But if it's something you do on big jobs, or you often have this, then it must be profitable to your business. So what you do, you make a list of all the parts, and to each part you stick the time, how much it will take to make. I think you need about twice that time for the entire assembly of the instrument, because finding the angles and soldering it and cleaning is a substantial amount of work too. That's how I arrive at the making time. And of course there's the fitting and the finishing. In the end you have to polish it and to pad it. Often you will have to lacquer or to have it silver plated or nickel plated. To this you will have to add the time for the consultation session and all the communication, which can be a lot. The parts you need are usually only a couple of pads and some screws, some parts, some pieces of brass, so that's not a lot, unless you use things like ball heads for photo tripods or monopods. Of course you have to calculate them in. After you've done adapting the instrument, it will often not fit the case anymore. So you might have to adapt the existing case, or you might have to adapt the existing case or make an entirely new one. It's difficult nowadays to find someone who makes cases. What I do, I find some sort of fitting case or I order one, and I'll make the interior myself with foam, which I then cover with fabric. Shipping, especially if it's far away, can also be a bit expensive, as our instruments are too expensive to send by ordinary post. So I use a service like DHL Express, which is costly. So best for your customer if he's in the neighborhood, pick it up from your place. So that was it for now. Thank you very much for watching. Leave your comments and questions below. I will be happy to answer all your questions. Next video is about calculations of key interactions. Thank you very much for watching. Bye bye.